Hello, so today we're going to be working in section 3.3, page 12 of your note packet, and we're going to be proving lines parallel. So up until now, guys, we've spent a lot of time practicing what to do with parallel lines and all the different angle relationships that we have. But now we're going to work backwards, kind of like using that converse that we learned about earlier this year. We are going to work backwards to prove lines are parallel. All right, so let's look at this first diagram. It says, are the lines HI, so right here, HI, and TN, are they parallel? Why or why not? Well, they certainly appear to be parallel, but we have to figure out a way to prove that they are parallel. So I saw these numbers, 61 and 23, and I was like, well, wait a second. If I add those together, that gives me 84. And then 22 and 62, that actually gives me 84. And I'm like, well, if this is the transversal, if LINE is the transversal, if the line is the transversal, and these angles are corresponding angles, and they're congruent, wouldn't the lines be parallel? And that is yes. Okay, it is a yes. The lines are parallel because corresponding angles are congruent. Okay, so that's actually pretty cool, right? We can work backwards thinking in that way. But what we also have to think about is always checking to make sure, even if they appear to be parallel, that they are, by using something like that. So now in the next question I ask you, are WI, so is this line right here, WI, and AN, are they parallel? Well, if you notice, this is 61 and this is 62. I mean, they're pretty darn close to being parallel, but because corresponding angles are not congruent, they are not parallel. I'm going to use the symbol for parallel. They're not parallel because corresponding angles are not congruent. Okay? All right, so if we don't have lines indicating that lines are parallel, then we have to see if we can figure out a way to make them parallel. And we can do that by proving some of our special pair relationships. Prove some of the special pair relationships. I'm calling those angle measures the special pairs. Okay? All right, so let's look at the next figure. Next figure, I want you to label this line M and this N, and it says find the value of X that makes M parallel to N. Okay, so I look at the angles that I have here. I have this angle and this angle. So those are corresponding angles. But in order for me to make the lines parallel, those corresponding angles would have to be congruent. So to find the value of X that would make them congruent, you set them equal to each other. So 3x plus 5 equals 65. I subtract 5 on both sides, and I get 3x equals 60. So x equals 20. So with x being 20, it will make this angle, 3 times 20 is 60 plus 5, it will make it 65. So the lines are parallel because corresponding angles are congruent. Okay? All right, let's look at another example. It says, which segments in the diagram are parallel? Okay, so I notice again that the angle measures are kind of different, but if I add these guys together, I get 60. And if I add these guys together, I get 60. So I highlight the sides of that angle, right? And I extend it till I get to the sides of the other angle. So the parallel lines would be AC is parallel to BE. Segment AC parallel to BE. All right, but you can see that 36 and 38 are not equal, so AD and BF, although they appear to be parallel, are not parallel. Okay, so basically what that is, guys, what we've just done is we've proved that corresponding angles were congruent, so the lines were parallel. That is a postulate. That is the corresponding angle postulate converse. I call it cap converse. Why is it the converse? Well, the cap, so the corresponding angle postulate says if two parallel lines are cut by a transversal, then corresponding angles are congruent. The corresponding angle postulate is the converse of that, the flip of it. If two lines are cut, not two parallel lines, if two lines are cut by a transversal, and corresponding angles are congruent, then guess what? The lines are parallel. There's my symbol for parallel again. So we always use the converse when we're proving parallel lines. So converse, parallel lines. All right. All right, so let's look at the next page and let's see what we can come up with. And we're going to jump to the second example, the alternate interior angle theorem converse. Okay, so right now you know that we've got the cap converse to work with. Cap converse. Corresponding angle postulate converse. All right, so let's see if we can prove the same thing with alternate interior angles. So I'm going to tell you that angle 1 is congruent to angle 2. Okay? And I'm trying to prove that the lines are parallel. All right, so the first thing I do is I get my given written. So I've got angle 1 congruent to angle 2, and that's given to me. All right, so again, I'm trying to get to the corresponding angle postulate converse. So I'm trying to get corresponding angles congruent. So I notice right away from the diagram, since I've used everything I can with my given, that I go to the diagram and I see vertical angles. So I see that angle 2 is congruent to angle 3 because of the vertical angle theorem. All right, so now because of the markings, we can see that 1 indeed is congruent to angle 3. And hopefully you're seeing that this is the transitive property because I'm connecting 1 and 3 via 2. All right, and because 1 and 3 are congruent, that means that K is parallel to N because of the cap converse. All right, well now we just used the cap converse to prove the alternate interior angle theorem converse, which says if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. I'm singing now. Can't help myself. Get excited about math. All right, one more proof. Let's see. All right, so now we've got the cap converse. We have the alt-int angle converse. We have the alternate interior angle theorem converse. And now we're going to look at the same side interior angle theorem converse. Okay, so again, we're going to use the cap converse to help us prove it. All right, so I look at my given. It says 1 plus 2 equals 180, and I'm going to get that written. There isn't any marking I can make on the diagram with angle 1 plus angle 2 equals 180. Okay? Why? Because you can't mark supplementary. Okay, but I decided to look at the parallel lines, and my goal, I wanted to have a goal. So my goal was to get angle 1 congruent to angle 3, because then I can use the cap converse to prove this theorem. All right, so I noticed that I've got 180 in my statement right now, so I somehow have to get rid of the 180. And I might have to use some things that I know about the diagram. So I said, well, if 1 plus 2 equals 180, I also see that 2 plus 3, angle 2 plus angle 3 equals 180. And that's because of the linear pair postulate, so LPP, linear pair postulate. We know that those two angles equal 180. So hopefully you're starting to get familiar with this next step. This next step basically says if they both equal 180, well then I can substitute this guy in for 180 in the other equation. So I get 1 plus 2 equals angle 2 plus angle 3. And that would be because of substitution. All right, so I'm hoping that your head's spinning a little bit because you're starting to see that what you need to do to get to your goal, my goal, I know that I have to do one thing before I get to my goal. My goal is 1 and 3 on opposite sides of the equals. So right now I have them on opposite sides of the equals, but that 2 is in the way and I want to get rid of it. So I'm going to state that angle 2 is equal to angle 2 by the reflexive property. The reason I have to do that is so that I can subtract it. And so in the next step, I get that angle 1 equals angle 2. And actually, really, all of these should be measure of, measure of, measure of, measure of, measure of, measure of. Okay, so measure of angle 1 equals the measure of angle 2. All right, and that would be subtraction. All right, So since the measure of angle 1 equals the measure of angle 3, I made a mistake there, sorry, rushing. Well, then we've reached our goal, and that means corresponding angles are congruent. So K is parallel to N because of the cap converse, corresponding angle postulate converse. All right, so now that just proves for us the same side interior angle theorem converse, which says if two lines are cut by a transversal, and same side interior angles are congruent, guess what? Then the lines are parallel. Woohoo! All right, so we've just proved that based on getting those special angle pair relationships congruent, we can prove the lines parallel. All right, let's look at an example. What values of x makes AB parallel to CD? All right, well, the first thing is you need to mark your diagram. I would have given you that is a right angle, okay? So in order for me to make these lines parallel, ABCD, then I need this angle right here, x and 40 together, to be a right angle. So to find the value of x that would do that, I would do x plus 40 equals 90. I'm going to subtract 40, and so x equals 50. So if x is 50, then we can now say those lines are parallel. All right, let's try another one. Find the values of x and y that make AC, so I want this line right here, AC, parallel to DF. Okay, all right, so I'm going to look at the x's first. So I see that if this is the transversal to those x's, if I can prove that these are equal to each other, then I can use the alternate interior angle theorem converse to say that AB is parallel to DF. All right, so for me to make them congruent to each other, it means I set them equal. So 3x plus 20 equals x plus 50. I'm going to subtract x and subtract 20, and I'll get 2x equals 30, and x equals 15. So if x is 15, then these two angles are congruent, and then therefore the lines are parallel. All right, let's try AE and BF. All right, well, if we know x is 15, then I know this is 65 degrees. So if I'm trying to prove AE and BF parallel, then this is the transversal to the y. And so I'd have to use the same side interior angle theorem converse. Oh my gosh, that's such a mouthful. And say that 2y minus 5 plus 65 equals 180. If I can prove same side interior angles are supplementary, then the lines would be parallel. So that's going to give me, I'm going to combine like terms, get plus 60. I'm going to subtract 60 to both sides, and I'm going to get 2y equals 120, and y equals 60 degrees, or 60. So if y is 60, then AE would be parallel to BF. Okay, so we're going to stop there for now. I hope you have a great weekend. If at any point you need to go back, I know it's a lot of writing today, and I will see you guys in class on Monday.